Hey guys, so today let's look at a voltage divider circuit and its operations. So let's consider a scenario where, as an engineer, you have a battery or a supply and which gives you something, let's say 12 volts, all right, 12 volts DC, and you have a device which operates on only 9 volts. So you got to take this 12 volt supply, but you got to make sure you only feed 9 volts to it. And a simple common sense thinking or logical thinking would tell you, okay, you need to somehow reduce the 12 volts to 9 volts. So you need to dissipate 3 volts. So 3 volts has got to be dropped. So that is the basic principle of working of a voltage divider circuit. So when you have a supply and when you have two resistors that are connected to it, this voltage will drop according to the value of the resistance. So depending on the values of R1 and R2, we're going to get different values of V1 and V2. So if I'm going to connect my device across R2, I just need to design the circuit in a way that I get V2 is equal to 9 volts. Right? So then I can take this voltage and then I can feed it to the device. So let us look at what a voltage divider circuit looks like. So it's basically nothing but a voltage supply with two resistors connected in series, R1, R2. We're going to call this Vn. And if I connect a multimeter or a voltmeter and I call this V out, so I'm going to get my voltage divided voltage, or whatever you want to call it. So if we use Ohm's law in this circuit, the main circuit, I get the potential difference or the supply voltage is current times total resistance, which is R1 plus R2. As simply rearranging the terms, I get the current is the total supply voltage divided by the total resistance. And now if I just apply Ohm's law to this one, if I just apply Ohm's law to this part of the circuit, I get the measured voltage, which is V out here, is equal to the current, which is the same current, times R2. And we already know what is the value of current, so we get the main expression for a voltage divider circuit as the supply voltage divided by the total resistance times the resistance of the resistor that you're measuring the voltage across. So this is our expression for a voltage divider circuit. You gotta know that you can also measure the voltage across here, across R1, but then this point is not gonna be ground or neutral because it's not connected to the negative terminal, whereas this point here is connected to the negative terminal of the battery, so it can be considered ground. So why we do not usually measure the voltage across R1. All right. So in our case, in our situation, we have a supply of 12 volts, and we're going to design the circuit so that we get 9 volts here. Okay. So I'm going to erase this. So I have a 12 volt supply. I'm going to connect it to two resistors in series, R1 and R2, so that I get 9 volts here. So according to the expression, we have V out is equal to V in times R2 by R1 plus R2. So it will be 9 is 12 times R2 divided by R1 plus R2. So if you just solve this, you would get 3 times R1 is equal to R2. So our circuit is now designed. So this is the condition. So if you want to have R1, or if you want to have R2 as 1 kilo ohms, then your R1 has got to be 3 times 1 kilo ohms, which is going to be 3 kilo ohms. And the value of this resistor, R2, depends on your supply voltage. So if it's 120 volts, you generally don't want to have just 1 kilo ohms. You want to have some kind of higher value. So that is how you design a circuit based on the voltage divider. And another thing I wanted to show you guys was kind of everything. So here we have our 12 volt supply connected to two resistors. So this was our R1, this was our R2, and we got 9 volts across this. So here is where you would connect your device, which requires a 9 volt supply, your electronic device, let's call it that for the time being. But this electronic device is also going to have some kind of resistance or impedance. Here we're not going to consider impedance because it is a DC circuit, but it is going to have some resistance. So this device that you're connecting can also be represented as a load resistance, RL. So when designing this kind of circuit, you also got to consider RL into the picture. So how that changes is very simple. You have your expression, V out is the supply voltage times R2 divided by R1 plus R2. So that's the total resistance, not considering the RL or the load resistance. If you do consider RL, you just merge R2 as R2 parallel RL. So the R2 term which was in the original expression becomes R2 parallel RL. So that is called the equivalent resistance. And better handwriting. So this is our equivalent resistance. So if you have two resistors, we have R2 and we have RL, which are connected in parallel. So if their equivalent resistance is going to be R2 times RL by R2 plus RL. So because that is the expression for two resistors which are connected in parallel. So that is the expression you're going to be using if the device that you're connecting also has some kind of resistance, which is called load resistance. But basically, in order to design the circuit, all you need to know is this simple formula. And then you need to know what's the value that your voltage value that your device operates on, and you need to know your supply voltage based on that, and also you need to know your load resistance value. So if you know these three values, you need to know V out, you need to know what's your supply voltage going to be, and you also know what's the load resistance going to be. You can take these and design your R1 and R2 so that when you take the voltage across R2, you get the desired voltage that you want. So that is basically the operation of a voltage divider. It has many applications, and I urge you to explore them, but just remember, when you have flow of current in a series resistance circuit, the voltage will drop. And this voltage drop is exploited. So if in our case we had 12 volts, we dropped 3 volts across R1 and we dropped 9 volts across R2, and we took this 9 volts and fed it to our device. Thank you.